Welcome back, everyone. Ready for another deep dive?
Always.
Today, we're going to be getting into something pretty fascinating. Well, it might sound a bit technical at first, but I promise it's going to be mind-blowing.
Oh, I love mind-blowing. Lay it on me.
Okay, so we're talking about compressing large language models, LLMs, those AI systems that can write you a poem, answer your questions, even generate code.
Oh, yeah. LLMs, they're amazing,
One.
but
There's a but.
they're huge like really huge. And that makes them hard to, actually use on anything other than a supercomputer.
Right, like imagine trying to run one of these things on your phone, it would probably melt.
Pretty much. So that's where this paper comes in. Low-rank adapters meet neural architecture, search for LLM compression.
Okay, I'll admit that title's a mouthful.
Yeah, it's a bit dense. But basically, it's all about how to make these incredible LLMs smaller and more efficient without losing any of their smarts.
So like slimming them down without making them dumb.
Exactly, that's the goal. And one of the key ideas here is using something called low-rank adapters.
Low-rank adapters, what in the world are those?
Okay, so picture this. You've got a massive Swiss Army knife, right? Every tool you could possibly imagine. But most of the time, you only need like one specific tool, like a screwdriver.
Right, I get that.
A low-rank adapter is like attaching a small, specialized screwdriver bit to that giant knife. You get the functionality you need without carrying around the whole bulky thing.
Ah, I see. So it's kind of like instead of rewriting the entire LLM code, you're just adding these little add-ons to make it work better for specific tasks.
That's a great way to put it. And the best part is these adapters can be fine-tuned much faster and take up way less space than retraining the entire LLM.
So smaller, faster, more efficient. But how does this actually affect, me, the person trying to use AI in everyday life?
Well, think about it this way. Imagine having access to really powerful AI assistants on your phone, ones that don't drain your battery in 5 minutes or eat up all your storage.
Oh, that'd be nice.
Right. You could have personalized AI for everything. Writing, learning, creative stuff. The possibilities are kind of endless.
Okay, that sounds pretty amazing. But this paper goes even further, right? It
Yeah.
mentions something called neural architecture search. NAS.
Yeah, NAS. That's where things get really interesting.
Does.
Remember our Swiss Army knife? Well, NAS is like having an AI architect who designs the most efficient layout for those adapter tools. It's like it tries out different designs, looking for the one that delivers the best performance with the smallest size.
Whoa. So we're talking about AI designing AI. This is getting meta.
A little bit, yeah. And the results are pretty impressive. One of the techniques they talk about, LoNAS, it uses low-rank adapters and NAS to shrink one LLM by 80%, while basically keeping the same level of accuracy.
80%. That's insane.
Right, and it even sped things up by like 1.4 times.
Smaller, faster, and just as smart. Not bad. What else do they come up with?
Well, they explore a bunch of different approaches. Each one has its own strengths and weaknesses. One that caught my eye was elastic LoRa adapters.
Elastic. So they can like stretch and bend.
You got it. They're designed to be super flexible. They can actually change their shape to better fit the task at hand.
Shape-shifting AI. Okay, now you got my attention.
So basically, they can adjust their complexity. Think of it like adding or removing tools from that Swiss Army knife adapter, depending on what you need.
I see, like becoming more specialized.
Exactly. They can even tweak how much they interact with the main LLM, which makes them even more efficient.
So we've got these elastic adapters, but the paper also mentions a technique called shears. Any relation to giving the AI a haircut?
Huh, not quite. But the name kind of fits, actually. Imagine you've got a tree with a bunch of branches, but some of those branches are like dead weight.
Pruning makes the tree healthier and more efficient.
Exactly. Shears works with LLMs that have already been pruned. They have lots of empty connections. And it helps recover any performance that was lost during pruning.
Ah, so it's like a win-win. Compression and better performance?
Precisely. And then there's SQFT, which takes shears a step further and adds this idea of low precision.
Low precision. What does that even mean in this context?
It's like using simpler numbers to represent things, which takes up less space.
Okay. So less data, but still accurate.
Exactly. SQFT uses some clever techniques to make sure we don't lose any crucial info when merging those adapters back into the LLM.
Clever is good.
Right. And there are even a couple more techniques they mentioned, SparsePEFT and QA-SparsePEFT, but those are more for dealing with specific challenges that pop up when you're using SQFT.
Okay, so we've got LoNAS, Shears, SQFT. It's a lot to take in.
It is. But it's Pretty mind-blowing stuff. All these giant LLMs, and we're finding ways to make them smaller and more efficient without sacrificing their intelligence. It's like fitting a supercomputer onto a tiny microchip.
It really is. And what's really exciting is that this research could make powerful AI accessible to, well, everyone, not just those with like massive computing resources.
That's the dream, right? Democratizing AI.
Exactly. But before we get too carried away with the possibilities, there's something I'm wondering.
What's that?
Well, if we can compress these powerful LLMs, what does that mean for, making this technology more available? And are there certain types of AI that maybe we shouldn't compress, even if we can?
Ooh, those are some big questions.
Hmm.
And they lead us to some pretty important ethical considerations. It really is, isn't it? All this incredible power potentially available to, well, anyone with a smartphone.
It's kind of mind-boggling when you think about it. What happens when cutting-edge AI isn't just stuck in labs and research centers anymore? What could that mean for, like, society as a whole?
It's like, imagine giving everyone access to a printing press. But instead of printing words, it's printing ideas, creative output, solutions to problems on a scale we've never even imagined.
That's both incredibly exciting and a little bit terrifying, to be honest.
Oh, for sure. It definitely raises some interesting questions. Like, think about education, for example. Yeah. Imagine every student having a personalized AI tutor, one that can adapt to their individual learning style and, how quickly they grasp things.
That would be amazing. No more, like, one-size-fits-all classrooms. Every student could learn at their own pace and really delve into the stuff that, actually lights their fire.
Exactly. And it's not just about personalized learning either. Compressed LLMs could revolutionize research, too. Imagine scientists in, say, developing countries who might not have access to those big supercomputers. Suddenly, they could run complex simulations, analyze huge data sets, all on a laptop.
That could lead to breakthroughs in, like, medicine, climate science, you name it. It's almost like democratizing access to knowledge and innovation.
That's the idea. And then there's the creative potential. Imagine artists collaborating with AI to create completely new forms of music, art, literature. What if AI could help us, push the boundaries of human imagination?
Okay, now I'm getting really excited. But with any powerful technology, there's always the risk of misuse, right?
Of course. That's why it's so important to have these discussions and to have, thoughtful regulations in place as this technology keeps advancing.
So how do we make sure this technology is used responsibly? What kind of safeguards do we need?
Well, for starters, we have to think carefully about security and access control. How do we prevent bad actors from, taking advantage of these compressed LLMs, using them for harmful purposes?
That's a big one. I mean, we've already seen how deepfakes and other AI-generated content can be used to spread misinformation and manipulate people.
Exactly. We need really robust systems to authenticate AI-generated content and help people figure out what's real and what's fake.
Transparency seems like it's going to be key, too. If we're going to be interacting with AI systems more and more, we need to understand how they work, what data they're trained on, any potential biases they might have.
Absolutely. And we need to develop ethical guidelines for the people who develop research and use this technology. It's like establishing a code of conduct for the AI age.
A code of conduct? That's interesting, almost like the Hippocratic Oath for doctors, but for anyone working with AI. Do you think that's something that could actually be implemented on a global scale?
It might be tough, but I think it's worth aiming for. We need to have a global conversation about AI ethics and how we can make sure it benefits everyone, not just a select few.
It's a lot to consider, but it's clear that this technology has the potential to, like, fundamentally reshape how we live, work, interact with the world.
And as we move forward, it's going to be fascinating to see how these compressed LLMs evolve, what new possibilities they unlock. Remember earlier when we talked about neural architecture search, or NAS, being like an AI architect?
Yeah, the one that designs the most efficient layout for those adapter tools, right?
Right. Well, the researchers suggest that we could take that concept even further, using something called evolutionary algorithms to optimize adapter design.
Evolutionary algorithms? That sounds straight out of science fiction. What does that even mean?
It's actually a pretty powerful technique inspired by natural selection. Imagine an AI system that generates thousands of different adapter designs, then tests them all out to see which ones perform the best.
So it's like survival of the fittest, but for AI adapters.
Exactly. And then the best performing designs would be bred to create new generations of adapters, with each generation getting more efficient and effective.
Whoa. So it's AI designing AI to make AI even better. This is getting seriously meta. It's amazing to think that we're really just scratching the surface of what's possible with this technology.
It's an incredibly exciting time to be following this field, that's for sure. But with all this focus on AI design and optimization, I keep coming back to the human element.
You mean like how this will affect us on a personal level?
Exactly. As LLMs become more accessible, more integrated into our lives, how will that change how we think, learn, create?
That's a good question. Are we going to become too reliant on AI, outsourcing our own creativity and critical thinking skills to these super smart machines?
That's a valid concern, definitely. But I also think there's a chance here to embrace AI as a collaborator, a tool that can help us push the boundaries of what we're capable of.
So, not fearing AI, but seeing it as a partner in exploration, discovery.
Precisely. Imagine a world where AI can help us overcome creative blocks, inspire us with new ideas, connect us with information and perspectives that we might never have found on our own.
That's a much more optimistic outlook, but I do think there's a balance to be struck. We can't just blindly embrace AI without considering the potential risks.
Absolutely. We need to be aware of the ethical implications, watch out for biases, and always remember that AI is a tool, not a replacement for human ingenuity and compassion.
Well said. This has been a seriously thought-provoking conversation, and I feel like we've only just begun to explore this fascinating topic, but I think it might be time to start wrapping up this deep dive.
I agree. It's been a pleasure diving into these complex and intriguing ideas with you.
Before we go, I want to leave our listeners with one last thought. We've spent a lot of time talking about the technical side of compressed LLMs, all the advancements and potential impacts. But what about the human side of the equation?
What do you mean?
Well, as we move into this new era of AI, what does it mean to be human? How will our relationship with technology change? And how will we define ourselves in a world where machines can think, learn, create right alongside us?
Those are some pretty profound questions, and I don't think there are any easy answers. But they're questions that we all need to be grappling with, not just scientists and engineers.
I couldn't agree more. You know, it's funny, we started this whole deep dive talking about compressing these large language models, making them smaller and faster, all that technical stuff. But now here we are talking about what it even means to be human in this age of, like, super intelligent machines.
It's kind of a natural progression, though, isn't it?
Yeah.
I mean, technology always has those kinds of implications, the societal and philosophical ones. And with AI, especially with these really advanced LLMs, it's just getting more profound all the time.
It really is. And I think it's important to have these kinds of conversations now, you know? While the tech is still relatively new, we need to be ahead of the curve on this, not playing catch up.
I completely agree. And the questions you brought up at the end there about what it means to be human, how our relationship with tech will change, those are things everyone needs to be thinking about, not just the scientists and the engineers.
Exactly. This isn't just some tech issue, it's a human issue. It's about our values, our ethics, even our future as a species, you know?
And it's about understanding that there's a lot of potential here, for good and for bad. We need to approach AI with a healthy dose of, I don't know, cautious optimism. We can embrace the possibilities, but we can't ignore the limitations either.
Cautious optimism. I like that because it's easy to get swept up in the hype or the fear or whatever, but the truth is probably somewhere in the middle, right?
Definitely. AI is a tool. And just like any tool, it can be used for good or for bad. It comes down to us, our choices, our intentions.
So what are some of those choices we might be facing? I mean, we touched on education and research, but how else do you see these compressed LLMs affecting our lives?
Well, I think one area we'll see a huge impact is in the creative fields. Imagine writers working with AI to brainstorm plots, musicians composing with AI assistants, artists creating these whole new forms of art that, blend human and artificial creativity.
That sounds pretty amazing, but does that mean like human artists are going to be out of a job?
I don't think so, no. I actually think it could lead to a kind of a renaissance of human creativity.
How so?
Well, if AI can handle some of the more technical parts of creation, maybe the more mundane things, it frees us up to focus on what makes us uniquely human. Emotion, intuition, that spark of imagination.
So it's not about replacing human artists. It's about like augmenting their abilities, expanding their horizons.
Exactly. And we could see this in other areas too. Think about doctors using AI to get more accurate diagnoses, lawyers using it to analyze tons of legal documents, engineers designing more efficient infrastructure.
It sounds like these compressed LLMs have the potential to change just about everything.
They really do. But that means we can't forget the responsibility that comes with it.
Right, absolutely. We have to be careful about how this tech is developed and used, make sure it's ethical, responsible, that it benefits everyone, not just a select few.
I couldn't have said it better myself. And that kind of brings us back to the whole question of, what it means to be human in this age of AI.
We've talked about a lot of the potential benefits, but what about the downsides? What worries you about all this?
One thing I think about is, well, jobs. As AI gets more powerful, it's inevitable that some jobs that humans do now are going to be automated.
That's a valid concern and something we need to be thinking about now. Like, how do we prepare for a future where some jobs just don't exist anymore?
It's a tough question, and there aren't any easy answers.
Hmm.
But I think education and retraining are going to be really crucial, giving people the skills they'll need in a future where the job market could look very different than it does now.
You're right. And it's not just about job-specific skills either. It's about being adaptable, being able to think critically, be creative. These are things AI can't really replicate, and they'll be even more valuable in the future.
I totally agree. And ultimately, we have to remember that AI is a reflection of us. We're the ones who create it, shape it, determine how it gets used.
So the future of AI is really in our hands.
In a way, yes.
Yeah.
It's up to us to make sure it enhances our lives, not diminishes them, amplifies our humanity, doesn't replace it.
That's a powerful thought, and I think it's a great place to wrap things up. Thank you so much for joining me on this deep dive.
The pleasure was all mine.
And to everyone listening, thanks for coming along on this journey with us. We hope you found this exploration of compressed LLMs as fascinating as we have. The future of AI is being written right now, and it's up to all of us to make sure it's a future that benefits all of humanity. Until next time, keep diving deep.